On May 16, 2025, Colonel David Levin pilots his F-15 IROM fighter, callsign 1, leading two formations breaking into Yemeni airspace at 24,000 ft. The jets are running dark. MCON alpha condition means there are no radar emissions and radar silence except for mission-critical communications. Intelligence has confirmed these ports are receiving Iranian weapons shipments destined for attacks on Israel and international shipping. This means this isn't just another strike mission. It's about protecting their loved ones back home. The desert coastline of western Yemen rises on the horizon. Visibility isn't great. Coastal humidity creates a light haze that extends about 15 km. Levin's targeting display shows the preloaded coordinates for berths 3 and 7 at Hidayah Port, where satellite imagery has detected unusual activity over the past 3 days. Temperature signatures from these warehouses don't match their surroundings, a telltale sign that something is not as it should be. At 15:44 hours, Sword 11 descends to optimal weapons release altitude. The internal navigation system counts down to the launch point. 87 seconds and closing. This strike package is flying completely on internal systems. No GPS signals that could be jammed. No radar emissions that would give away their position. The F-15S maintain precise spacing between aircraft, each jet positioned to maximum coverage of the target area, while minimizing the chance of detection. This is when the squadron's thousands of hours of training pays off. The F-15 IROM these pilots are flying is Israel's customized strike variant of the F-15E Strike Eagle, optimized for deep penetration missions like this one. Looking at the aircraft's wings and fuselage, there are 11 hardpoints capable of supporting a total payload exceeding 23,000 lb. Its twin Pratt & Whitney engines push the aircraft to over Mach 2.5, giving it the speed and range needed to strike targets across the region with minimal warning. At 15:45 hours, Sword 111 visually acquires Hidayah Port superructures, twin cranes rising more than 100 m above the western dock. The targeting interface projects precision aim points onto the crew's display panels, outlining a line of storage buildings. Levin's breathing grows slightly heavier as the weapons officer flips the master arm switch. "Oh, systems! Now live and armed!" There's no turning back. The aircraft tilts gently to port, aligning the crosshairs over the fuel depots. At exactly 15:46 and 27 seconds, the first missile separates from the launcher. The F-15 instantly sheds weight as the 340-kilogram bomb clears its mount. 4 seconds later, the formation disperses, each aircraft veering sharply in opposing directions. Rampage missiles streak across the sky, carving thin contrails toward the shoreline. The F-15I's extended range and terrain-hugging flight path allowed the Israeli jets to approach the Yemeni coast undetected by radar, safeguarding the vital advantage of surprise. Without the jet's 1,600 km combat range without aerial refueling, the IDF would have been forced to launch from closer proximity, increasing the chance of early detection by Houthi defense systems. But the operation isn't complete yet, and this is where the targeting pod becomes critical. At 15:47, Sword 111 activates the Lightning Pod's wide-area scanning mode. The central screen reconfigures instantly, presenting a thermal scan of Hidayah Port with remarkable clarity. Even in the dense coastal haze, the pod's multispectral image enhancement cuts through with ease. The FLIR module auto-adjusts its gain, optimizing contrast between ambient desert temperatures and heat radiating from port structures. Ada's port appears in sharp, high-definition detail. Cargo handlers move between buildings, but 2 warehouses stand out due to abnormal thermal patterns. One structure in particular draws attention. Its surface is nearly 4 dg warmer than its neighbors, despite receiving the same sunlight exposure. That's a red flag. The system quickly locks onto the anomaly, tagging it for strike evaluation. It fits intelligence reports suggesting a hidden weapons stockpile. But thermal readings alone aren't ideal for confirmation. Then, right on cue, the pod's optics pick up a box truck reversing into the western loading bay. Thermal imaging registers the difference between the truck's interior and its outer shell, a heat retention signature consistent with munitions, where metal holds warmth far longer than surrounding materials. That clinches it. The team has identified their key objective. The Rafael Lightning 35 targeting pod, now in use, is Israel's top-tier electro-optical suite for surgical air-to-ground missions. Mounted on the F-15I's right intake station, it integrates FLIR, CCD-TV, and dual-mode laser guidance within one unit. Weighing about 200 kilograms, it delivers capabilities that older generations needed multiple aircraft to achieve. With this system, the F-15I becomes a complete strike platform. At 15:48, the Lightning pod begins laser designation, firing coded light pulses that reflect off the warehouse at precise intervals. It self-corrects for the jet's motion, holding the laser spot within 15 C of target despite airframe vibration and speed. The Popeye missile seeker detects the laser bounce, confirming a 97% probability of hit. The weapons officer verifies the fire solution. Levin gives the order. Weapons free. The missile falls away, its engine igniting moments later. Instantly, the Lightning pod transitions to damage assessment mode, zooming out to monitor the full strike zone. The impact follows almost immediately. The warehouse roof surges past 200 DC as the warhead punches through. Within moments, a chain of secondary blasts erupts at 2-second intervals. Unmistakable proof of what the crew had long believed. This was a heavily stocked weapons depot. Thanks to the Lightning pod's laser designation and auto-tracking capabilities, both targets were neutralized precisely, and all while keeping radio silence intact. Without this advanced system, the pilots would have been stuck relying on static GPS coordinates, ineffective against moving targets or rapidly evolving tactical conditions. But here, visually spotting a truck pulling into the cache turned a best-guess strike into a confirmed hit. While optical guidance was sufficient for confirmed targets, the team still had to identify threats hidden underground or camouflaged against radar. And for that, they had to break MCON and activate their primary radar. At 15:48, Captain Sarah Navin aboard Sword 14 rolls towards Sail of Port for the mission's second phase, but a complication arises. Meteorological sensors register a dense cloud layer cloaking almost the entire port, reducing visibility across 90% of the zone. The Lightning pod's thermal view struggles to see through the thick atmospheric moisture. Passive sensors alone won't be enough. They need active radar. It's a pivotal moment. Breaking MCON could alert the Houthi defense grid to their location. But without radar input, the strike cannot proceed accurately. Faced with two choices, abort or proceed under risk, Naveen decides. Activating radar, she calls out, bringing the AN/APG-70 system online. The radar shifts from low-altitude terrain following to synthetic aperture mode. After a short initialization, the beam begins scanning beneath the cloud layer, rendering data no other sensor could provide. The F-15I is now broadcasting detectable signals. But its side lobe suppression minimizes its radar footprint, making it harder for hostile systems to lock on. It's a deliberate risk, but a manageable one. On the cockpit screen, a detailed radar map of Sail of Port begins forming. The radar outlines storage tanks as distinct circular shapes, while pier structures emerge as long, blocky extensions into the water. Despite the altitude and weather, the radar feed sharpens with impressive fidelity. Then, an anomaly. A structure just northwest of the primary dock. The data suggests heavily reinforced construction. concrete and steel significantly denser than typical port buildings. The radar's return echoes match those associated with hardened bunkers or underground fuel sites. It's the exact kind of installation satellites might miss, but could serve as high-value infrastructure. This is what they were hunting. The Rampage missile's penetrating warhead was built for targets like this. The F-15I's APG-70 radar is a long-range, multi-mode fire control platform, tailored for both air superiority and precision ground attack. Housed behind the aircraft's forward nose cone, the system features a mechanically scanned array operating across a range of frequencies. The radar antenna's tilting capacity, in both azimuth and elevation, allows comprehensive coverage regardless of the aircraft's maneuvering angle. This versatility lets pilots maintain optimal flight paths while continuing to map terrain and lock targets with pinpoint accuracy. At 15:49 and 13 seconds, the radar intercepts an electronic signal bearing 85, matching the signature of Houthi coastal defense radar. Analysis places it 28 kilometers out, beyond the known threat envelope of their SAMs. Still, it's a timely warning. Time is short. The APG-70 completes the targeting solution, calculating altitude, release timing, and transmits firing data to the Rampage missile. The onboard systems confirm full missile readiness. With all parameters green, there's only one step left. At 15:49 and 42 seconds, the Rampage drops cleanly from the pylon and plummets below. Captain Navan banks away, already plotting her return heading. The radar's job is complete. It delivered targeting clarity in conditions that neutralized every other sensor on board. Without this capability, the mission would have failed, or settled for a lesser impact. The missile is now en route to the fortified objective, entering the final and most critical phase of its flight. At 15:49, Captain Naveen observes as the Rampage missile's solid fuel motor fires up, thrusting the weapon to nearly 300 meters per second within seconds. This isn't a conventional bomb drop. It's a supersonic, purpose-built projectile designed to breach hardened installations. Its carbon composite frame heats intensely as it breaks the sound barrier. The aerodynamic fins make constant microadjustments to counter shifting coastal winds, keeping the missile precisely on track even through unstable atmospheric conditions. Every phase of the missile's journey follows a strict sequence: an initial boost for velocity, a cruise segment for range, a controlled descent to approach altitude, and finally, the terminal dive for the strike. Throughout, its navigation systems retain exact accuracy, even while pulling over 7 Gs in its final corrective turns. In the endgame, the missile drops to an altitude of just 30 meters. Too low and too quick for most radar systems to effectively register or intercept. Checkpoint Alpha is reached on time, with the missile screaming past at more than 620 knots. It skims the surface, radar altimeter constantly feeding ground clearance data to ensure it remains under detection thresholds, yet above terrain obstacles. This is no simple munition. It's a guided, highly engineered weapon executing a surgical strike with deadly precision. The enemy doesn't even realize what's happening until it's too late. At 15:50 and 24 seconds, thermal sensors aboard orbiting satellites pick up a massive heat spike exactly at the target location. The missile has impacted successfully. Infrared readings confirm it penetrated the facility before detonation, just as planned. Moments later, a cascade of secondary blasts erupts as internal fuel and munitions ignite within the underground structure. The supposedly hidden installation is now engulfed in flames. This Rampage missile, fired earlier from an Israeli F-15I, is no ordinary air-to-ground weapon. It's based on the extra artillery system, retrofitted for aerial launch and high-speed precision strikes. From its place under the F-15's wing, the missile's compact nose, which houses advanced guidance systems, and signature tail fins are clearly visible. Measuring 4.7 meters and weighing in at about 570 kilograms, it carries a 150 kg warhead designed specifically to pierce nearly 2 meters of reinforced concrete. Its mission: eliminate fortified strategic targets that would otherwise require close-range bombing. Meanwhile, over at Hidea, a second Rampage is deployed from Sword 21, this time homing in on the Crane Foundation at Berth 3. During its terminal phase, the missile hits Mach 1.5 as it plunges toward its objective. The steel-tipped nose pierces reinforced steel effortlessly, leaving an entry channel before the delayed fuse sets off the warhead. The resulting internal explosion sends overpressure waves coursing through nearby underground infrastructure, igniting volatile materials and causing secondary explosions. The shock wave devastates structural supports across a large zone, collapsing the critical link between the dock and the crane. Months of engineering work are wiped out in an instant. Follow-up satellite scans later confirmed the obliteration of both targets. At Salif, the underground fuel reserve spikes to over 800 DGC in under 60 seconds as petrochemicals ignite in an uncontrolled inferno. At Hidea, more than 60 meters of fortified dock at Berth 3 are annihilated. Rampage missiles provide Israeli pilots with the crucial ability to neutralize hardened targets from standoff ranges, eliminating the need to fly directly over heavily defended zones. Without these systems, the mission would have required high-risk bombing runs, putting lives and aircraft in danger. Yet the operation isn't over.